Last example we'll do is an example where pretend we've got a tank here and water flowing both into the tank and out of the tank. We've got an inflow and an outflow. Water coming in, water going out. Maybe you got a faucet up here and you got a drain down here, right? The net flow rate, maybe I should add the words rate to these things, inflow rate and outflow rate. The net flow rate is the inflow rate minus the outflow rate. What am I talking about here with flow rates? I'm talking about how fast is the water filling the tank, or is it being emptied? Rate. What might typical units of this be? Probably the most standard units would be like liters per second or milliliters per second. You could also use gallons per minute or something like that. Let's pretend it's in liters per minute. That's a little easier to imagine than liters per second or milliliters per second. How much is a liter? Fills up something about this big. This is some function, f of t, and let's go ahead and pick a function. How about, cosine of t plus 1/2? And I'd like to figure out what the integral of this flow rate is over some interval of time, and what does it represent? What interval of time should I pick? I think I'm going to pick 0 to pi. So from 0 to pi seconds, 0 to 3.14 seconds approximately, I'm going to integrate this flow rate, cosine of t plus 1/2, get an answer in 1 minute here, and then try to interpret what it means. Use the fundamental theorem of calculus. We can do it here. What's an antiderivative of this? Antiderivative of cosine is sine. Why? Because the derivative of sine is cosine. Antiderivative of 1/2 is 1/2 t. Why? Well, differentiate 1/2 t, you always get a half. This goes from 0 to pi. You evaluate this function at pi. Subtract what you get when you evaluate the function at 0. This all does become 0 again. Sine of pi is 0. The answer is pi over 2, about 1.57. What does that represent? The flow rate is in liters per minute. Time is not measured in seconds, it's measured in minutes. I said 0 to pi seconds, it's 0 to pi minutes. What's dt measured in? Minutes. If you pretend this is a product, the minutes cancel, leaving you with units of liters. And when you integrate or add up a quantity that's in liters, the end result is also in liters. So what does it represent? Change in volume. This is the change in volume. And it could have been negative. It wasn't here, but it could have been. The flow rate graph does go negative over the interval in question. It looks about like this. This is the f of t here. Our answer is this area minus this area. The area there happens to be bigger than the area there, so we got a positive answer. But if the area below was bigger, we would have gotten a negative answer, and the change in volume would have been negative. In general, the integral of a rate of change gives you the change in the quantity. The integral of a velocity gives you change in position. Integral of a flow rate gives you the change in volume. Velocity is the rate of change of position. Flow rate is the rate of change of volume with respect to t.